I am.
It says, which of the following is not function? Do you know, I think this first one's probably x squared.
Yeah, it's gotta be. I'm sorry.
Okay. That's okay. Like a couple of them has, but that's okay. The way that we do this is we have to figure out, well, what is f of negative x in each case, or in this case, g of negative x. So let's just go through them one at a time, because that's you'll learn some things along the way here. So when we do a, g of negative x means negative x quantity squared. What does that simplify to?
Negative x.
Just x squared, because it's like saying negative x times negative x. Okay, so if that's true, all right, then this is then it becomes x squared, because the two negatives make a positive. Now, the way we know if it's an odd function or not is, first of all, does this equal the original function?
Yes, it does.
So that means it's even. All right, so it's a little bit, we'll do the next one here. Maybe it'll make more sense. So g of negative x for letter B, 5 times negative x minus 1. When you simplify this, you get negative 5x minus 1. Do you agree with that?
Yes.
Okay. Is this the same as the original?
No.
No, it is not the same. So when it's not the same, the next thing you do is you factor out negative 1. So it's negative 1 on the outside. And then what goes on the inside here? So you're basically changing the sign of each of these. Do you remember that from?
Yeah.
Might have even been our first.
5x plus 1.
Okay. So now you have to ask, I have to ask you sort of the same question. Is this part inside parentheses the same as the original? It has to be exactly the same.
No.
It is not. So it is not odd. So therefore it is neither.
Right.
All right. Now I want to skip over C and go to D, because D is the one we're kind of interested in here. D is g of x equals 4x. So we're going to do g of negative x. We're going to put negative x in for x. So this becomes negative 4x. Is this the same as the original?
No.
No, it is not. So the next step is to factor out negative 1. So this becomes negative 1 times 4x. You just change the sign of whatever's here. Is the same as the original?
Yes.
So that makes it odd. So the progression here is, and so the answer is D. The progression is it's either even, or it's odd, or it's neither.
Right.
Is that okay?
Yeah.
All right. Number 2, look at number 2 next here. It's got a couple of formatting issues I think I can interpret, though. Okay, so first thing here is, are you pretty sure that this is 2 minus x squared?
Let me double check, but I'm pretty sure.
Okay, and actually we're missing, like, it might be doing composition here, like r of w of x or w of r of x. You might want to check that also if you can.
Yeah, it's x squared, and it's that's so weird. And it is w with that circle in the middle r.
Okay, like this.
Yeah.
Okay, so this is composition. If you remember from our very first lesson, you start with this one, the one on the right, r,
Yeah.
and then w is the second one. All right, so
Right.
what this means is you take whatever r of x is, which is this 2 minus x squared, and you put it in for x wherever you see an x.
Right.
So r of x's are inside, we start with that, and we take it and we put it into our outside function. So this becomes 2 minus x squared instead of x minus 2.
Yeah.
So notice that the 2's cancel and you're just left with minus x squared. Because this one's positive, this one's negative.
Right. Okay.
Now, do you know what the graph of just a regular x squared looks like? Do you remember that?
Yeah.
So x squared is a U-shaped graph.
Yes.
Okay. Negative x squared, though, is going to go the other direction. It opens down. Now, why do we need to know this? Because we're asking about the range. The range is the y values, whatever the y values work. So I believe this first one is indicating negative infinity to 0.
Yeah, I copied it from my teacher's review thing, but like I couldn't save the review on my computer. That's why I copied it, and apparently it did not want to put
No
the
problem.
infinity in it.
No problem. So and then the next one here is probably 0 to infinity. And then 2 to infinity. Okay, so when we go down and look at our graph, the range in words is bottom to top, or if you prefer, min to max. Okay. And if I were to ask you a question, how far down does this go? How far down do these lines go?
To infinity.
Negative infinity. Right? You start at negative infinity. And then what's the maximum point? It's actually right here at the origin. So the maximum value that it takes on is 0.
Oh, okay. That makes sense.
Okay, so the range, you can think of these words over here on the right. There's so many examples, though, I can't necessarily just be like, yeah, here's the one that always works. You have to kind of know what the shape of the graph looks like to be able to answer this question. Okay, so as always, please, if you want another one like it, let me know. We can always do one at the end if we have time. But please stop me. That way, there's plenty of understanding. All right, a cashier earns $7 an hour. Okay, this must have been written a long time ago. I mean, even minimum wage is double that now. If X is the number of hours worked, okay, so if you work 1 hour, you get 7 times 1. If you work 2 hours, you get 7 times, you get 14.
Right.
And if you work 3 hours, you get 21. So what is changing each time?
The X value.
So 7X.
Okay.
Don't be surprised if you do get a few questions in the test that really are that straightforward.
Yeah, I've gotten those. It was the first thing that we covered in Algebra 2 was like the easy problems. She gave us word problems and we had to make the equation for them.
Oh, good. Good. So there's a lot of techniques you can use, but sometimes there's nothing overly complicated about it. All right, now I know it's tempting to read all this, but what the question is really asking for is what's down here. And sometimes you just got to cut through all that and go to that. So k minus h of x, because there's an operator here, subtraction, this means k of x minus h of x.
Okay.
And like similarly, let's say it was like, I'll just do this. Let's say it was x. Let me not do it that way. So let me go like f minus p, plus p of x. This would be f of x plus p of x.
Right.
Okay. All right, good. Now on the left here, do we have a function for k of x?
Yes.
Right there, 9x minus 2. Do we have a function for h of x?
Yes, we do.
Okay. Minus, now this is where you got to be careful because it's subtracting the whole thing. So really, whenever you subtract, you want to use parentheses. because this negative has to distribute to both terms.
Okay.
So we have a 9x minus 2 minus 5x minus 6. Is it clear how I got those values from the previous line? So now you combine like terms, 9x minus 5x.
Right.
Which is 4x. And then you got minus 2 minus 6.
6 is -8. There
you go. And then you just have to match it up with the right answer there. So looks like letter C is correct. You notice I did this without the multiple choice. Unless it specifically says like which of the following, you really want to try to do the problem without the multiple choice and then just, oh yeah, there's my answer as a confirming step.
That makes sense.
Okay, let's go to 5. I'm just going to do these in order tonight. I mean, normally I do try to look around to see if there's some sensible way to do it.
It's not like the test is going to put them in order.
Well, that's a great thought. Like, why not? But I'm not making your test. So, all right. Lionel computed the average rate of change in the depth of a pool over a 2-week interval to be 0. Okay. So let's talk about what average rate of change means before we go any further. There is a formula. Average rate of change is y2 minus y1 over x2 minus x1. It's literally your slope formula. Now, it's not presented that way because that's slope, but I wrote it that way because I wanted you to see that it is exactly the same. F of B minus F of A over B minus A.
Right. I remember going over that.
Okay, so let me rewrite this. Instead of, let's say Lionel computed the slope to be 0. The slope is 0. If the slope is 0, what kind of line is that?
It's this.
It's straight, but is it up or down, left or right, sideways, diagonal? What is the slope of 0? So vertical lines have undefined slope. This is a horizontal line. Horizontal line. Okay. So some people remember this by thinking about when you look out into the horizon and you maybe see the sunset. When you look out into the horizon, you're looking out sort of in this direction. Like imagine you're standing there.
Yeah.
That is one way to remember this. You have to know this. Like this is really important for math. It's really important that you know this right away. So because we can't answer this question without it. So we've taken a bit of time to diverge. Let's go back and actually look at the question again. Lionel computed the average rate of change, which I keep telling you is slope,
right,
and the depth of the pool over a 2-week interval to be 0. Okay, so here's a graph. Let me actually grab the question again, and we're going to make a graph. Okay, of here is the depth of the pool, and this is time. Okay, so let's just say it's got a slope of 0. Do you agree that's a slope of 0?
Yes.
Okay. And let's call this 200 gallons. I don't know if that's right or not. And let's say that this is on day 0, and then on day 1, 2, 3, 4, 5, 6, 7. So we'll call that 14 days later.
Yeah.
So if I give you these two data points, 0, 200 and 14, 200, what is the slope going to be when you calculate it?
0.
0. So what must be true? And we're gonna read these, but like, and I know you want to go to read them, but like a little bit of work beforehand will help. The water level is the same at the start and the finish.
Right.
Okay. So now that you know that, it's easy to read each of these and actually say, oh yeah. Now, must the pool have been empty for the entire interval? Well, maybe, but that would mean it was down here at 0. Okay. what does the next one say? The pool must have been at the
same depth.
And is that what this suggests here?
Yes.
Yes. Now, just as kind of a related question, let's say the average rate of change was negative. What would that tell you about the water level?
It gone down.
Okay. So like maybe it's draining out. What if it was going up?
Then it had increased somehow.
Right. Maybe it rained or somebody put water in the pool. We don't really know. All right, question 6. All right, what does this notation on the right indicate? Do you recall from an earlier problem?
Yes, that indicates that G is going to go into F.
G of X goes into F of X.
Yeah.
And this is called composition. Okay, so which is F of X? I'm sorry, which is G of X?
F of X is 3x squared and G of X is 4x
cubed plus 1. So G of X goes into F. So this goes into that right there. So this is 3 times 4x cubed plus 1 squared.
Right.
Now, we talked about how to FOIL this, and we kind of have to answer this question. So this is 4x cubed plus 1 times 4x cubed plus 1. That's literally what this 2 means. It means you multiply it by itself. All right. Now, if these 2 are multiplied first, what does that become? Well, 4 times 4 is 16. X cubed times x cubed is, now when the bases are the same, you add the exponents.
Okay.
Bases same, add exponents. So sometimes it's good to have both the written way of understanding it and then the formula to go along with it. So what is 3 plus 3?
6.
6. Then the outer. So the outer is 4x cubed times 1. So that's 4x cubed. The inner is 1 times 4x cubed, which is the same thing. And then the last is 1 times 1, which is plus 1. If we multiply each of these by 3, which we're going to do next, it's 48x to the 6th plus 12x cubed plus 12x cubed plus 1. And then we probably should have done this in a previous step. We can actually combine like terms. Now I've gotten so deep into this problem, I have to go back and actually look at like what it is asking for. And if you look on your paper there, you'll see that it's saying, what is the degree? The degree. So the degree refers to the highest exponent, the largest exponent. What is the largest exponent in this problem?
The 6.
So the degree is 6.
I didn't know that's what the degree meant.
Yes, it's the highest exponent. It could be 0 up to any exponent that you see.
Okay. Makes sense.
All right. We've tackled the first page. We're ready to move on to the next page. For number 7, you'll probably have to clarify what is written because I don't. It's this the symbols did not copy through. So, can you tell me what should be here?
Yeah, just give me 1 second. I gotta find it. Oh, wait, there it is. Okay.
Actually, hang on. Let's do it differently. I want to show you what each of these are, what each of these properties are, and then you look at yours and decide which one is correct. Okay.
Okay.
Okay. So the we're going to start with the commutative property of addition. The commutative property of addition. So what this says is A plus B equals B plus A. And what it means in real words that are meaningful is if you add two things together, like let's say you add 7 towels and 3 towels, it's the same as 3 plus 7. The order doesn't matter. Order doesn't matter. Okay.
Mm-hmm. Right.
So now maybe that's not it, but we're going to knock that out. The distributive property. Okay, we actually just kind of did that. They generally put a C on the outside.
Okay.
The C is times A times B. So this is CA plus CB. Okay, so some like I normally do it, and we just did that. Let's say it's 2 times 4 plus 3. Okay, so 4 plus 3 is 7. 2 times 7 is 14. But what if we use the distributive property? What is 2 times 4 plus 2 times 3? So this is 8 plus 6, which is still 14. Now you would never, like you would always add first, but like maybe seeing it this way, you'll see, oh, that's what they mean by that. You distribute in.
Right.
Get it. Okay. All right. Now the identity property of addition, we'll do that one next.
Mm-hmm.
Okay. So this one says, what do you add to a number to get back the same number? 0. If you add 0 to something, you get back to what you started with.
Okay.
Let's look at an example. What is 8 plus 0? It's
8.
Right. Now the identity property of multiplication means take X, and what do you multiply X by to get back to X?
0.
1. No, not 0.
Right. Yes. Sorry.
And I kind of led you down that little trap there.
Yeah.
It's if you multiply by 0, it goes away. 1 is itself. One keeps it. Okay.
Yeah.
So now that you've seen each of these, can you answer the question on your page?
Yes, I can.
Okay.
Thank you. Actually, the last one we worked on, well, not the multiplication, but the addition. Just added 0 to it and got the same thing.
Let me know when we can go on to the
next one.
Yep.
I'm ready.
All right. So this one, boy, a lot of word problems. Okay. The height, let me snip it in. So this problem, we're going to do it the way we've been in the last few, which is we're going to like work through the part that's given and then look at the answers after we know what's given. So I know it's hard, but try not to focus on any of that stuff and let's just look at what's there. It says the height in feet of a model rocket T seconds after launch is given by the average rate of change. So the average rate of change is, and you've seen me do this a few times, it's y2 minus y1 over x2 minus x1. It's the slope formula, but it's written kind of differently. It's f of b minus f of a over b minus a. And someday you will totally believe that these are exactly the same formula. So the value of b is 3, that's b, and a is 1.
Mhm.
So let's put it into this formula. F of B is 3, A is 1 over 3 minus 1. Do you see how all I did was substitute those values for A and B?
Yes.
Okay. They actually tell you the average rate of change. They tell you it's 6. That's also given the problem. Do you see where it says is 6 in the problem?
Oh yeah.
Right back
Yes.
there.
Okay.
Okay. Now, a little simplifying on the right, the bottom is 2. And if you multiply both sides by 2, you get 12 equals f of 3 minus f of 1.
Right.
So give me a number that when you subtract another number, you get 12. And if it's not clear what I'm asking, like I can give you one. Is 20 minus 8 12?
No. I mean, yes.
Yes,
So.
yes. Okay. So I try to ask you questions that are I am not trying to trick you ever.
I
I'm
know.
this is very direct. Can you
Yeah.
give me another number and give me another number that equals 12 when you subtract?
22 minus 10.
Okay. Now I'm going to come up with one. 15 minus 3. Can you give me one more?
13 minus 1.
Perfect. What do you notice about all the numbers in this first column compared to all of the numbers in the second column?
All the numbers in the first column are bigger than 12.
Okay, so that means that the height here must be bigger than the height here.
Okay, that makes sense.
So now I'm going to snip in the answers and let's see if we can go through them and see if there's one that kind of is the same way of saying that. So take a look at these and see what you think.
So C.
Okay, so at C it says it's 6 feet higher. But what did we say the difference was between them?
12.
12. So that one is out.
Okay, so then it's B.
Is definitely B, yeah. I was hoping you would see the greater height. These are really, by the way, these are really hard. Like I think this is unfair to you, but I was trying to get you to see through height that one is bigger than another when you do this.
Yeah.
All right. Do you like to read? And if so, are you reading any good books right now?
I do like to read. I like the Limoncello series, and it's about these kids that get trapped in a library and they have to go through some crazy challenges to get out.
I see. And like, would you say like how many books do you read per like month or week or like kind of give me an idea of how much reading you do?
I mean, I try not to do it while doing school because then I get really mad when I put the book down.
I see.
That's how committed I am. I will read the whole book the whole day and I won't do any work. It's like a TV show to me. So I would say that I got I would probably go through 12 or more a year. I can go through
Good.
one a day, to be honest.
That's great. Reading is just essential. I'm really curious, and we have plenty of time here to get through everything, but when you see a problem like number 8, do you at all read it the way you read your books?
No, I have a really hard time reading it. I just see a bunch of numbers and a bunch of words, and I don't think the numbers should be with the words.
That's totally fair. but what about the multiple choice? Is this any better for you? The fact that it's just a statement or a clause or is it because
Not really.
okay.
But I know it should be, but it's just like I'd rather them say it's 36 or 32 or something like that. I'd rather just give me a number.
Okay. So I'm not trying to argue with you, but hear me out here. Like, what if your books just said that they found the door and were able to exit the library? Would that be very compelling?
No.
So you gotta give this one a little bit more. I don't know what the right word is, but just kind of like try the next time you see some of these problems, maybe try looking at it in some of the same ways you read the books that you really enjoy. You may start to see things in here that help you to answer these questions. Okay.
Yeah, I get that.
And I actually have a worksheet that I think you might really like that would help. So I'll send that to you at the end, or we'll look at some if we have time here. But let's go get back to what you want to work on.
Mm-hmm.
This is asking about this part right here.
Yep.
Okay. Now, if it was k plus k of x, this means k of x plus k of x. Do you agree with that?
Oh, yes.
Now, with the 4, what is different is that instead of x, it's 4. It's k of 4 plus k of 4.
Right.
Do you agree with that? Is that
Yeah.
okay? Now, here's k of x. So we need to go and figure out, well, k of 4 is 5 times 4 minus 6. Okay.
Mhm.
And then if we're going to do it again, so let's say, let me do it differently. Let me put this down here. Get rid of those. And then let's add k of 4. What is the next k of 4 going to be?
The same thing, 5.
I actually mistyped this. I apologize. 5 parentheses 4 minus 6. And then, yes, it's going to be exactly the same. It's going to be 5 parentheses 4 minus 6. So your instructor has this tendency to not give you the number, but give you kind of the like appearance of the numbers with the operations.
Right.
How's your matching? Like, can you see which one this is now? This line.
Yeah, this is D.
This is D. Okay.
It kind of drives me crazy because I want to solve it.
Yes. Yeah. You want to take a step, but there's nothing to do in that step.
But yeah, I see how we got there. That makes sense.
All right. Which one? I think we're up to 10.
Yes, we are up to 10. These ones make me a little bit confused just because I'm not sure how much my teacher expects me to take the parentheses. Like, I know you say to put in parentheses and I do, but I'm not sure how much my teacher really does that. Like, I don't know how much she wants to apply that.
This one's not formatted great, but I'll try to emphasize what it is. So I believe this is x squared minus x plus 8.
Yes.
Okay.
Yes. They all should have those little arrows. I'm sorry that they don't.
That's okay. Let's go through the steps of how you figure out whether it's an even function. And to do that, you're going to put negative x in for x.
Okay.
So that's negative x squared minus negative x plus 8.
So you don't touch the other numbers, just to be clear.
When you say other numbers, I guess give me a little more information. What do you mean by that?
No, I mean, like, we don't make it negative 8 instead of a plus. Like, we don't make everything a negative, I guess.
What this literally means is wherever you see an x, put in negative x, and there is no x where 8 is.
Right.
So you don't touch it. It's like have you ever seen the when builders come in, they sometimes tie a ribbon around a swirl or a tree. Like, you don't touch that one because it's off limits, but everything else you replace.
Right.
Now, one of these, I'm pretty sure A, B, C, and D looks like one of this, but I'm going to say it's probably B and D just based on this.
Yeah, I see why you would say that. Yeah.
Okay, now we need to simplify this, which means we need to evaluate the exponent. So this is x squared plus x plus 8. So let's go through that. Negative squared is positive. X squared obviously becomes x squared. Two negatives make a positive. And like you said before, the 8 is untouched.
Yeah.
So because it's even, you look at this right here, and this is, you want to know whether this right here is the same as the original. It is not.
No.
But now we got to kind of answer it in the multiple choice. So what you're hoping for is, does this part, if it's even, equal the original?
Right. And that's, yeah, what?
So what's a little odd about this is that this is not an even function, but the instructor is like saying, well, what if it were an even function? How would you check that it is an even function? And
right.
it's by putting negative x in for x, which we did, and then comparing it to the original.
Right.
So now let me watch this. This is the kind of if I would really love to see one of your exams, because then I could even better help you out with this stuff. But let's say this said odd. It's the same first steps. Okay. But now it's this one. Because remember how you have to factor out the negative? Yes.
And because they don't want us to actually do that, we would just put the negative on the outside. Well, yes. And change, well, we didn't change the signs, so they just put the negative on the outside.
Yes.
But yeah. Okay, that makes sense.
All right, question 11. Okay, for which pairs of function is, what is the word for this right here? What is the symbol mean, this bubble?
Oh, composition.
Composition, yeah. And
sorry, because we've been talking about like the problems not being correct. I was like looking at the other problem, trying to figure out why it was wrong.
No problem, no problem. So the g of x, we start with that, you know that, and then f is the outside function. So when it says for which or which of the following, you actually kind of do have to go through each one. So we're going to just do these one at a time. So for the first one, and I'm going to snip it down, okay? For the first one, you take the g of x, which, let me snip this in. You take your g of x and you take this part and you put it in for x. So wherever you see an x, you replace it with 16x minus 3. And I always show it in parentheses. I think you'll find that that's easier. So now we do need to simplify. This is the distributive property. Now, question to you, are we distributing 4 or negative 4? And it's not a trick question, but I want to know what you say here.
Negative 4.
I like that. So because it's negative 4, this becomes negative 64x. Negative 4 times negative 3 is positive 12. When you combine like terms, it's 15 minus 64x. And we're trying to get it to equal 12x. So this is no. Right.
Because even if we divided it by, I mean, if that was 12, it would have been a lot more simple. But yeah.
Okay, so we're gonna recipe here. We're gonna rinse and repeat. Again, we're gonna take the second thing and put it in wherever we see an x. This is 6 parentheses 2 over x squared.
Right.
Order of operations says that you exponent before you multiply.
Yeah. So then we would just expand it, right? We would just make that twice, or no?
It's 2 times 2, which is 4, x times x, which is x squared.
Okay.
Now you can multiply the tops. And again, this is not 12x squared. So again, we say no. I'm going to go to letter D because letter C is cut off with the functions.
Yeah, that's okay.
So again, just like the others, you take this and you put it in wherever you see an X. So it's 4 parentheses 3x, which is
12x,
which is what we
our
want.
answer.
Yes. Okay. We have a choice here. We can do more problems like these. We can do some of those word problems that I mentioned earlier. This worksheet I've got that I think you might like. You get to decide though, what would you like us to do with the remainder of the time we have today?
I don't want to do it for the remainder of time, but I did come across this problem and I wasn't sure how to solve it. I know it's on the worksheet. I'm sorry about that, but
That's okay.
I probably should have. But it was composition, but instead of the like 0 or like the O in it, it was F over G. And I wasn't really sure what to do.
So let's go back to, so what this is it's f of x divided by g of x. Okay, and let's go back to this one. And we'll do a few others. And the question could literally be, it would then say, comma, what is f over g of x?
Yes, that was like the question.
Okay, well now you know, now that you've seen this, you're like, okay, I just take the f or whatever top letter is, f of x, which is 4x, over g of x, which is 3x. This is your answer, but you have to simplify. Do you see how I just put whatever f of x is on top and whatever g of x is on the bottom?
Yes. So that I would do that with anything, right? Like any equation.
Right. Now this one's
each other.
Yeah, this one's simplified, so it's not a great example. Let's go back to this first one. And this one does not simplify. So this is the more common case that you would see. You would say, comma, what is f over g of x? So it's literally f of x divided by g of x, which is 3 minus 4x over 16x minus 3.
Okay. So I was trying to solve it like the other one, and then I was like, well, then what did I do about the division? And that wasn't really working. So I'm glad that, yeah. So you just put them over each other and then solve.
Yeah. Well, that's it. There's nothing to do. This is your final answer.
Right.
Like there's nothing more to do after this. Like it's done. Okay, let's do this will be, let me do something with you here that I think you'll like. I think it'll be helpful. Let's say f of x is x squared plus 1, and let's say g of x is 5x plus 2. Okay, what is f plus g of x? Could you just verbalize what we're going to do?
Yeah, that you would put f, so x.
It's plus though. It's plus though right here. Plus, not a bubble. It's just a plus.
Right. So you just add the two equations together.
You add the two functions together. Yes. Okay. Now we're not going to simplify because we don't have enough time, but I want you to see all the possibilities here. What are we going to do this time? F minus g x.
And you minus the two functions.
So it's like this minus parentheses fx plus 5x plus 2. Now be careful because I could also ask you for g minus f of x, and the order matters.
Right.
So this would be 5x plus 2 minus x squared plus 1. So here's another one. I could say, what is f times g of x?
And then we times the two function.
You multiply them together. This is your FOIL that we talked about. Okay, I'm just gonna copy the F and G again down, and we'll keep going on this. So the next possibility is the one you just asked me about. What is F over G of X? Well, it's X squared plus 1 on top, 5X plus 2 on the bottom.
Right.
But couldn't I similarly say G over F of X?
Which would be 5x plus 2 over 2 squared plus 1.
Okay, now let's do the last two that you might see. Okay, so the last two that you might see are the composition F bubble G of X. Okay, and I don't know the format of your exam, but the bubble should be very clear, whereas the multiplication should really be a thin dot or filled in dot. This has got to be an open circle. It's very different. This means F of G of X. It means take this one over here and plug it into the other one there. So that's parentheses 5x plus 2 squared plus 1. You're taking whatever the inside function is and putting it into the other one.
Right.
But notice you can also go the other way, and it's not the same. It could be the same, but it's not. It's G of F of X. And this time you take X squared plus 1 and you put it into the other function for X.
Right.
I did not simplify any of these. You would be expected to simplify them. Although the format your instructor gives, sometimes he just wants you to show the, like your instructor may actually keep like the answer like this up here.
Right.
But what we did in the last like 5 minutes here, that's the summary. That's the conclusion. If you just look at these notes, you will probably fully understand what's happening here at the end, because that's it. There's not any other variations on this.
That makes sense. That makes a lot more sense.
All right, well, that does take us to the end of our lesson for today.
Okay.
So I really appreciate you scheduling. I think this helped a lot. I'll send you the notes here shortly, and I'll see you next time.
Oh, could you also send me the sheet for the word problems, or maybe we can go over that next time? But
I'll put it in the email to you, and you can just go to my website and download it. I think you'll like it, and if you don't like it, you can tell me why you don't like it, because I'd love to hear if you think it's good or bad.
Okay.
All right. Thanks, Emma. I'll see you next time.
Yeah.
Bye.